Okay, good morning, everyone. Welcome to ATD2 Industry Workshop. My name is Yoon Jung, and I am Chief Scientist of ATD2 project. And focus of this breakout session is to give you an overview of ATD2 surface decision support capabilities that we developed and evaluated in Charlotte Airport since September 2017 throughout phase 1 and phase 2. And this breakout session has both slide presentation and the live demo of ATD2 surface decision capabilities. We'll make sure to spare some time, like 15 minutes toward the end of this session for Q&A. So please feel free to use your application on your iPhone conference.io to submit your questions. You'll make sure that we have about 15 minutes toward the end. So before we move on, let me introduce our presenters. I'm sort of, session chair here. So on your left, Father Isaac Robson is a senior analyst from Mosaic ATM, has many years of experience in surface CDM, including development of surface CDM ConOps and design of the software, currently working on ATD2 project as lead of surface mirroring. And from my right, Liang Chen is a software lead for ATD2 surface scheduler and metering and integration of surface scheduler with the terminal scheduler for phase 3. In the past, Liang worked on various ATM projects as software lead, including TMA and terminal sequencing and spacing for ATD1 project and many other projects, I believe. So let me just get started our presentation. I'll give you overview a little bit and then switch over to hand over to Isaac and Liang for presentation and a demo. So okay, today's breakout session agenda: ATD2 overview and electronic data exchanges, common situational awareness, surface scheduling, and departure scheduling for overhead stream insertion and surface metering. These are the major capabilities of ATD2 for phase 1 and phase 2. So let me just jump over to the next slide. This is the overview slide of ATD2 project. A lot of you in the audience may have seen this many times. Let me just quickly go over the environment that the ATD2 is working on. So first, we see the upper portion of this slide shows the en route airspace, center airspace, divided by the dashed line, which shows home center airspace and neighborhood adjacent center or centers. And then at the bottom, there is a 2 cylinders here. Big cylinder is a TRACON or terminal airspace. Big cylinder is like a home TRACON airspace, and the small cylinder over there is like a adjacent or neighborhood TRACON. And then there are multiple airports inside the big cylinder TRACON airspace. Right now, just notionally, there are only 3 airports. One is sort of big airport, a well-equipped airport, advanced technologies for surveillance and other technologies. And also there are small airports, less equipped airport, which may not have advanced surveillance and other technologies. So we are dealing with all these different, level of, equipages, airport, and so that's sort of, overall, ATD2 operational environment. And then all these oval shapes are the control points where all the controls are applied. So, for example, blue dots are for departure control points, and red dots are for arrival. So all the arrival and departures, fly through those, control points, and then yellow dots are for surface constraints. And next layer is sort of a constraints layer we are talking about. The funnel on the upper side represents the imbalance between capacity and demand downstream airspace. So that will impose some restrictions or constraints over to terminal airspace as well as airports all the way. And this thunder clouds the boundary of terminal airspace represents some weather activities which may close departure fixes, multiple departure fixes, so that flights have to reroute to other departure fixes and things like that. Yeah, so those are sort of constraints layer, and there is another constraint layer, overhead stream. There it imposes another constraints for departures to be inserted in this overhead stream in the en route airspace. And then lastly, there is a trajectory layers. So all the departures from multiple airports in the terminal airspace needs to be scheduled and fly through those departure fixes, and arrival also scheduled to arrive at the airport through the arrival meter fixes. And then lastly, the trajectory from home terminal airspace may be departing from airport and then flying into the adjacent terminal airspace, which may have another metering arrival constraints imposed over those departures. So these are sort of operational environment for ATD2 project throughout the phases. So phase 1, 2, 3 addresses all these issues related to these operations in huge area to make integrated arrival departure surface. But phase 1 and phase 2 are more like surface related problems and also overhead stream insertions. So that's sort of in the focus of our breakout session presentation. Okay, and this slide shows the major capability of ATD2 project for phase 1 and phase 2. So ATD2 is a collaboratively developed in coordination with multiple partners, including the FAA, flight operators in Charlotte Airport for phase 1 and phase 2, and DFW for phase 3, and also NACA and General Aviation. So we have very big partners throughout the project. So you have heard all those partnerships in the plenary session this morning. So ATD2 has been developed in response to the recommendation from Next Generation Advisory Committee, and FAA has selected Charlotte Airport as demonstration site for ATD2. So ATD2 started like 2015, and first phase field evaluation started end of September 2017. And these are the images of 4 major capabilities that Isaac and Liang are going to show throughout this breakout session. So collaborative service metering and overhead stream insertion and data exchange and integration and digital transformation of airport service situations. Okay, so this slide shows ATD2 capabilities in terms of building blocks, sort of depicted as layers of building blocks, different capabilities. So at the bottom of this pagoda says real-time electronic data exchange, which is the fundamental or foundational capability for the entire ATD2 system that provides common shared situation awareness among various users, including ATC Tower, TRACON, Center, and Airline Ramp Tower. On top of this layer is surface scheduling, which provides the trajectory from gate to the runway, and also prediction of departures for overhead stream insertion. So that is big, most important part of ATD2 capability, and it also generates some metering advisories to airline ramp controllers, which is on top of that layer, surface metering for phase 1 and phase 2. And also for phase 3, we developed a departure fix load balancing capability, which will schedule departures through the departure fixes especially in a better weather situation, departure fixes can be closed, and then this capability proposes rerouting options, trajectory option sets that airline submitted to ATC. So this all scheduling is capable of handling all these different situations, both surface as well as terminal boundary trajectory planning. And on top of that is policies and processes and procedures, which sets the roles and responsibilities of the users to maximize the benefits of this IAD system. So, so with that, I'd like to hand over to Isaac to go over the details of each major capability, and as we go on, Leanne will show the live demos, in parallel.
Thank you, Yoon. So as Yoon said, we're going to be working our way kind of up this column, and so the first step is electronic data exchange, and we're going to try and get through these slides pretty quickly so we can get the demo, which I think most people probably want to see instead of staring at boring slides. So this is just an overview of the kind of architecture of ATD2. So we start over there on your left with the getting data from external systems. And that's the data fusion from external systems using swim data, data from FAA systems, data from airlines. And throughout the session, I'll be pointing you to, this is an overview, where you can go to find out more about this. The tricky one with this is that the fusion of data is actually happening right now. So if you want to get up and leave, feel free to, but the fusion session is happening in the main hall we were just in. You can also go look at Swift slides that we presented a couple months ago on that to learn more about what we're doing with data fusion. We ingest that data into the flight matching and fusion, and then we pass that data along to our IADS model and scheduler, where we predict where the flight is and we add value to that. We also ingest TMI data and do a lot of TMI processing. There's an entire track on TMI processing. So if you're looking at your schedule, that's the gray sessions. And then we just fuse all that data together. We do modeling and scheduling and then metering. And we display that data on our STBO client, which is more aimed at ATC. The ramp does have access to that, but it's more the ATC tower view. And then we also display that on our ramp traffic console, RTC. And we'll be talking more and demoing that today. We have an entire track, 2 sessions on RTC. If you want to go learn more about RTC, those are at the end of tomorrow. And then as we add all that value, we publish that data back out through the TTP feed, the TFDM terminal publication service. We're doing that in advance of TFDM, and we have another session on that later today, the end of today, on TTP. And that's a very good feed, and that's what you as industry will be receiving the TFDM data through. So that's an overview of the ATD2 architecture. So we're going to start down at the bottom with the electronic data exchange. So how are we enabling electronic data exchange? How are we getting rid of phone calls, people having to pick up the phone and call each other and pass information along? We're doing that. We're talking back and forth between ATC, the tower, and ATD2, and the airlines. In this case, ATD2 is kind of serving as a surrogate for TFDM and what the future tower system will be. So the airlines are passing in data, the EOBTs, the gates, the tails, to TFMS. TFMS is republishing that through SWIM, and ATD2 is consuming that. In the future, TFDM will be consuming that EOBT data. And then, as I just talked about, ATD2 is publishing data back to the airlines through TTP. ATD2 is also, as I said, providing the RTC tool to the ramp controllers to get that information there. And so that is a NASA-provided example of what a vendor tool could look like for a ramp system. And so we really want the industry to go learn about what we put into RTC. What lessons did we learn? How does information displayed? What information do those ramp controllers need? One note is RTC is an ATD tool. ATD-2 tool, so where it's integrated with that. In the future NAS with TFDM, you as airlines, airports, vendors are going to have to be providing that tool yourself. And so the question is how to get the data from TFDM onto your ramp tool, and that's going to be where the TTP feed comes in. So do you route that data back through your operations center? Do you have your vendor connect directly on your behalf and get the TTP data? As an airport, are you an airport CDM member, and can you get that data yourself? These are all questions that we want to get the ball rolling as TFDM's coming and get people thinking about as we transfer this knowledge to industry. This is just an overview, once again, of TTP. We are ingesting a lot of data, fusing it all together, adding data, and then publishing it back out to a lot of different consumers. So the mobile app, which we'll talk about a little bit more, air carriers, airports, and industry, data, predictive analytics, so a lot of different uses. Speaking of the mobile app, there's a session on that later today, after lunch. Talked about a little bit in the previous session, we're getting data from GA. It's important to get the data from the GA community and be able to for them to be able to provide EOBTs into our system through a mobile app. That data has never been available before. That's electronic data exchange that has never been able to happen. And then we're providing data electronically back to the GA pilot so they can understand kind of what's going on at the airport and what they can expect as an individual flight. We are supporting an ATD2 electronic data exchange in the tower cab. We're not going to demo the AFS system, but this is more ATC focused, but we do support, we integrate with the Advanced Electronic Flight System, which TFDM is going to be replacing. And so data that ATD2 has, we electronically send over to the tower cab, to the controllers, to local control, ground control, clearance delivery, so they know what TMIs each individual flight has. If the airline says, hey, this flight needs a longer runway, that information gets communicated across the TOBTs and TMATs. And in the reverse direction, when a controller enters, hey, this flight is going to this runway, we've changed the runway, that gets electronically communicated back to ATD2, which gets distributed to the ramp. So all of these are phone calls that would have to take place in the past, or communication over the radio with the pilot. So when the pilot gets to the spot, says, hey, I need the long runway. Today, that information is already communicated before the pilot even gets to the spot. And from an operator perspective, this helps too, with electronic flight strips and TFDM. It's a benefit to you as airlines as well, because you're cutting down on the time it takes to reroute a flight. A controller's not having to run around the tower cab looking for a strip when a reroute happens. That electronically happens, and you get that update. So with TFDM coming, there should be a lot of benefits just from the electronic flight strips themselves, and we're seeing that today with ATD2 and AFS integration. Traffic management initiatives, back to that. Bob will be talking about a lot about this right after this in this room and in the future sessions as well. But right now in the NAS, you have to enter a traffic management initiative into a lot of different systems. ATC has to do it. It's a lot of verbal communication between the tower and the ramp. We're trying to cut down on that. We're trying to say, an ATC personnel makes some entries into NTML or FSM. Both of those are TFMS tools. It creates a GDP, creates a miles and trail restriction. It says we're app-repping this destination. Today, that's a phone call to the ramp. Which flights are affected, that's not really very easily determined. ATD2 is picking that data up from a couple of different sources. We're getting that from OIS. So we're scraping the OIS page. We're also using the SWIM TFM data flow, which has the restrictions in it, and ground stops, GDPs, that type of information. We get the edicts as well. So ATD2 is trying to transform the NAS through electronic data exchange of traffic management initiatives, which cuts down a lot on verbal communications. So that's it for the data exchange, electronic data exchange portion. We're going to go through a couple more slides and then get to the demo. But before I do, are there any questions on the, Rick? Yeah. Could you actually, there's a microphone back there. Yeah, sorry.
Your flow chart that spoke to TMI analysis. It's one of the first couple of slides. I just wondered what assumptions go into that TMI analysis, and do any of those assumptions have to do with the use of route structure?
So we do look at the route, and we identify if a flight is affected by like a miles and trail or anything like that based on the route that it's flying, if it's passing through which fix, if there's a miles and trail on a jet route, that type of stuff. We're not currently dealing with reroutes, TMIs in ATD2. That's been a request for phase 3. I think the phase 3 folks could probably speak to that more, and if you want to talk to them. Yeah. Question, if you could.
Yeah, can you go back, I think, 2 slides, please? No, that one, that right there. So who's the driver of this slide? Are you guys developing this slide and the data elements that are within it?
So this is the AFS Team. This is an FAA product. It was meant as a prototype for what electronic flight strips could be. Right now it's maintained by the Tech Center, I believe. And we're just integrating with it. We met with that team, talked about what data elements we wanted to exchange, came up with a list, developed a kind of a one-off interface. This will all be within TFDM. So this is the future system that's coming. They're going to have electronic flight strips. They're using this as a, what can we learn, what do we need to put in there, and how do we want to display data from a surface system. They're also building the surface system, the model, and the scheduler. So it'll be one kind of seamless product.
What about the ability for a flight operator to give important information via this tool, such as FAR 117s, crew legalities, those types of things, and taxi out, 3-hour tarmac rule? When we get to a certain threshold, somebody that right now we do a lot of phone calls or
Right.
go through the command center,
Yeah.
the TCA webpage. I could see where this could be a valuable electronic exchange of information that would streamline that whole communication process.
So we're getting there. So if you go back to this slide, I listed kind of a few key data elements that are initial data elements that airlines are sharing. There's a lot of other data that you can share. As to like the 3-hour tarmac rule, you know, TFDM allows you to see what the delays are on a flight, and you can see kind of what the delays are in individual flights. As to crew legality and other things like that, TFDM will allow some substitution inside a metering program to help with that. But saying this individual flight needs to be off by this time is still going to be a phone call. But in the future, you know, we're trying to move towards more electronic communication, and that maybe is a data element that should be shared, you know, at future points in time. Oh, sorry.
Yeah, I think, I don't want to get into the weeds on spin here, but on your last slide, you know, one thing I found interesting, we have been told that the NTML data doesn't completely feed into SWIM, or that SWIM doesn't accurately depict everything in NTML. And I was interested to note that I think you said that you actually scraped the current restrictions page also.
Yeah, so there was a bug identified where APREC restrictions were not coming through the SWIM feed. That is being fixed and should be coming shortly in the TFM. There is the other issue where, depending on how entries are entered into NTML, they don't always show up in either OIS or in SWIM feed. So, you know, we've been working with the ATC operators to make sure that they get entered in a way that we can receive the data and parse it electronically, so they're not having to enter it into 2 different or 3 different systems. That's going to, I think, could be a training thing as TFDM rolls out, how to make sure that restrictions are entered into NTML correctly, so that you're not having to enter them in NTML and into TFDM, trying to make sure that TFDM can pick them up through the SWIM feeds.
Now, if you take the NTML data and
We do some matching. So the way it works currently actually is we use the OAS page at Charlotte and we use the SWIM feed for restrictions at DFW. We do internal matching to make sure, and there's going to be a session on kind of how all this TMI matching happens. But yeah, we do try to make sure, identify it's same fix, the times have changed. Okay, let's just update the time instead of create a new one. We're working through that and had some struggles, but working with the ATC operators, we've been able to identify that and make improvements, and we're getting a lot better. I would love to say we've eliminated all manual entries into ATD-2, but there's just some lags, but we're getting much closer to being able to cut down. We've definitely cut down on the number of entries and getting better as we progress. So on common situational awareness, once we have the electronic data exchange, we can now exchange the data and show it to users so that both ATC and the airlines and the airport have common situational awareness about what is happening at the airport. So as I mentioned before, we have two main systems. We have on the left here, we have the ramp traffic console and a slightly modified version with some additional capabilities called the ramp manager traffic console, RMTC. And then on the right, we have what is primarily the ATC view of surface trajectory-based operations client, STBO client as we call it. And the great thing about ATD2 is when you enter data in one, it shows up on the other. So that's, ATC and ramp know which flights are affected by TMIs, which flights, what the airport configuration is. In TFDM, this data will also be available. It's just a matter of ingesting the TTP data feed and getting it onto your ramp tools. So this is the ramp view. I'm not going to spend too much time on these slides just because we're going to demo it, and these are just there for people to go back and look at. But there's going to be 2 full sessions on what all the nomenclature means, what all these different indicators mean. We're going to hit some highlights of it today, but if you are interested, and I would highly recommend anybody that's working on the vendor tools or an airline in the ramp area, please go to those ramp sessions at the end of tomorrow. They're going to dive into everything we've learned, what all the different markers mean, and that'll, I think, really be enlightening for folks. So if we could go ahead, Bobby, and switch over to Liang's display. So we're going to be zooming in and out just because of the size of the text here. Bob, if you could turn the lights down a little bit. Yeah, make it a little bit easier to see. So this is the STBO display. So first, as a matter of orientation, you'll notice that the airport appears to be upside down. So Charlotte, the top of the map up there is actually south. That's because the tower and the ramp tower are there down at the bottom of the map, and they tend to look out and think of that as up. So we allow them to rotate the map to orient it the way they normally do. And then on either side of the map, you'll see 2 timelines. So at the bottom of the timeline here, we have current time. The few flights you see down below, current time, are actual flights that have either landed or taken off. And above are predictions. So the flights in gray are arrivals, and the flights in green are departures. And so the timeline over here is for the east runway. The timeline on the other side is for the center and west runways. So this is 18 left, 36 right, which is a mixed use runway, and over there is the center runway, which is primarily departures, and then the far right timeline is the far west runway, which is solely for arrivals. On the map itself, the flights are color-coded based on runway. So the blue flights are for the east runway, and the brown flights are for the center runway, and then the green flights are arrivals on the map. With the map, Leong is demonstrating how you can move around. We also allow zooming out. You can zoom out and, for example, see the terminal airspace. And then you could actually see arrivals coming in from all over the NAS. So a lot of times the TMCs and the ramp managers will have a separate view where they're looking at the TRACON airspace just so they can quickly switch back and forth and see where the arrivals are and how close they're coming. So that's a quick overview of the STBO. Leong there is showing a gate conflict. So that's another piece of electronic data exchange that we have. So we show that on the timelines, on the maps, which flights we're predicting a gate conflict for. We also now send that over to the electronic flight strips. So at Charlotte, they have basically an arrival list in their electronic flight strip tool, and we flag which flights have a gate conflict. And so we're working through with the controllers there on procedures for how to coordinate with the ramp so that they can see, okay, that flight has a gate conflict. What does the ramp want me to do with that? In the future with TFDM, there's intent data elements to say, do we want to hold that flight in the movement area? Do we want to hold that flight in the ramp? We're working through that with ATC and the ramp there at Charlotte. So speaking of the ramp tool, Leong, if you wouldn't mind switching over to the, this is the RMTC ramp manager tool. You can see it's more focused on the ramp itself. We have basically flight strips moving around with each puck. If you hover over it, you get it blooms to show additional information. So once again, the brown flights are going to the center runway, the blue flights are going to the east runway, and the green flights are arrivals. So just at a glance, the ramp controllers already know this flight's calling me for pushback, which runway should it go to? The purple flights you see out there are arrivals with gate conflicts, as we were just talking about. And then at the gates, you'll see some circles and some squares, some gray circles. And so that circle that Leong is pointing out right now is actually a pushback. But then the gray circles and the gray squares are just flights or aircraft sitting at the gate that are not expected to operate for a while. But we're still considering the gate occupied. So I think we'll, if we go back to STBO, one additional thing to show is there's a flight list down at the bottom. Down here, this flight list, if you is customizable. We allow them to create flight lists based on set of criteria. In this case, this is the standard one that they have set up. Yeah, so there's the set of fields you can pick from, and then there's also a set of filters to what to filter down. This is the standard view that the TMCs in Charlotte Tower have, where they're looking at filter down to APREC flights, because this is one of their main jobs is to negotiate release times into the overhead stream. And so it's filtered down, and this is, and so then when, yeah, there we go. Yeah, thank you. Yeah. So you can see some call signs, destinations, departure fix, aircraft type, gate, standard information. EOBT is a key data element that I'm sure most people here are familiar with. If you're not, it's the earliest off-block time. It's the new data element that's saying, the airlines are providing, saying when the flight will push back. AOBT is actual off-block time, when the flight actually pushed back. And then we give the ramp, the TMCs a view of the status. So they know which flights are probably going to be calling, and then which APREC time they requested and the actual APREC time. When the TMC makes entries into this STBO client, it shows up. So, for example, right now, if you go to the airport configuration, TM actions, and then So we allow the TMC to change the airport configuration. This used to be a phone call between the tower and the ramp because the ramp has to taxi aircraft to different spots depending on which runway they're going to. So we're currently in Northflow. Right now we have what they call the Beats configuration where the BV's Andes Taylor's off of 36 Center. But for example, if we change the configuration to well, yeah, we'll go crazy and send everybody to the mixed use runway. But so we've made that change now. The system's going to start reflecting that. You can see now that we've got a lot of flights over there. There's a few flights over on the other runway just because of where they are in queue. We're now predicting everybody to go to that runway. And if we flip back over to the ramp view, you can see that everybody now has automatically updated. That used to be a phone call between the tower and the ramp, where the ramp had to then enter into their system as well, and there was, so they knew which runway a flight was going to. An additional advantage is that the TMC can cherry pick flights over to a different runway. So if you go back to STBO and pick a flight that's at the gate, and the TMC can search for flights, search for departure fixes, and then they can say change runway. And so they can change it to the center runway, for example. That will update the schedule and on the timelines. And then if we go back to the ramp tool, sorry to be jumping around so much, that was, we now see that one flight in brown there. So no longer does the TMC have to call down and say, hey, you're going to that runway, you need to taxi that flight to a different spot. That's immediately electronically communicated. Conversely, if we pick a flight that's going, a blue flight that's going to the east runway, and let's say that flight needs the center runway for weight and balance, they can open up the flight menu on that flight and change the runway, say, yes, this is really an operational necessity, it's for weight and balance, say we need the center runway for that, and apply. Now that switches to the center runway, the runway is highlighted in green, and if we switch back over to this display, we now see that flight up there on the timeline saying operational necessity, and that shows up on their flight strip as well saying they need the center runway for operational necessity. That actually is a data element that you can send as an airline through SWIM to TFDM. You could send a list of acceptable runways. These are the runways that we as an operator need for this flight because of weight and balance. Just something to keep in mind. One thing we do, common situational awareness, is taxiway closures and runway closures. So you're seeing there on the map that there is there's a taxiway closure. Same thing happens if a runway closes, we can see that. Also, the ramp can close. Sorry, I'm jumping around. Let's close a ramp. So that's up under tools, and then yeah. So the ramp manager can say, lightning struck, the ramp is closed. This is a busy time period. You don't really be picking up the phone, calling the TMC. TMC is probably already busy. Maybe can't answer the phone. You're busy. It's one click. The TMC immediately knows ramp's closed. This is another data element that you can send into TFDM through a separate interface, the TFCS, which will be talked about in a later session as well. So that's just some of the data. If we can maybe open the ramp back up, and then speaking of TMIs, we show TMIs on the flights. So the yellow squares up there, for example, that's an edict flight. So the ramp controllers already know which flight they have an edict, have an APREC. It's okay. You can move your mouse up to the top and then. But there's electronic data exchange of the TMIs. So when the TMC assigns a release time to a flight, that is electronically communicated to the ramp. So the ramp knows that. That's a data element that's available in Swim now, and it'll be available in TTP as well. So that the tower, so that queue there at the end means that flight also needs a release time going to Newark. So when the TMC assigns a release time to that flight, that'll get electronically communicated. They can go ahead and communicate that to the pilot. And you can see there we're recommending a 74-minute hold for that flight. In this case, we're saying, hey, Delta flight, it's time to push back because to comply with that release time. So let's see how we're doing on time now. We got about 30 minutes left. So we'll go ahead. Bobby, if you could jump back to the slides. Or I got a question in the room real fast.
Yeah, do you have any modeling capability to say, hey, in 90 minutes from now, we're going to have lightning, we're going to have a ramp closure for 40 minutes. What is that? How do I look at that and analyze my inbound flights? How many gate conflicts we're going to have? That surface manual piece of it.
Yeah. So there are some what-if modeling capabilities. You know, a lot of that would be through updating EOBTs and things like that to let us know that the flight's going to be on the gate longer due to the ramp closure. You know, so we do have some what-if modeling capabilities, more focused on airport configuration changes, trying to figure out which one balances the runway the best. You know, that's a lot of the predictive analytics that you know, we're trying to get into as we move forward as to kind of what's going to happen. Yeah, so I think ideally that's where we would get. Right now, modeling of ramp closure would not change the gate conflict.
I think what a lot of people don't understand is that RTC and RTM, they don't come with ATD2.
Right.
Because the airlines, they will even have to incorporate some functionality to develop or incorporate whatever tool they are recommending for traffic management. So this connectivity between STBO is going to be all through TTP?
Through TTP, and then some of it, like the ramp closures, would be through the TFCS, which is a request reply directly with TFDM. And there'll be a session mostly focused on substitutions, but it's that same interface. That's later tomorrow, actually. Yeah.
Can you address the structure that incorporates TMI into a TD2? How that
The pre-departure.
Yeah.
So that's probably closer aligned with phase 3. So Charlotte, we're not running that type of capability. Yeah. Yeah. So that's where you're trying to like change your routing to get around weather.
Yeah, and we were told it would be in phase 3, and I just wanted to
Yeah. So.
if that is still the case and where that would fit in the architecture.
So right now with phase 3, we basically have a kind of a pseudo PDRR capability in ATD2 where we have a list of toss options and the TMC can see that and the airline submit which one they want and then they select it. It's not actually using the PDRR capability itself, but it's there'll be probably more discussions about that during the panel tomorrow, and then there's another session at the end of tomorrow as well. So we've already talked a little bit about surface scheduling in the demo, but before we did scheduling, we did modeling. So kind of to your question, this is more, when we say modeling, talking about where is the flight currently? You know, where is the flight going to go? Which gate, spot, runway, fix is it going to use? Creating a 4D trajectory through that is an undelayed trajectory, and then tracking the aircraft line of flight to predict gate conflicts. So we've already seen some of that, but that's kind of the foundation. You know, before we can even predict when a flight's going to take off, we have to know where is it currently, where is it going, and how would you think it's going to get there. And then once we have the modeling done, we can do the scheduling, which is most easily seen in the timeline, where we're predicting a takeoff time for every flight. In phase 3, we're predicting a fixed crossing time for every flight, deconflicted with the entire TRACON area. At Charlotte, we're just focused on the Charlotte airport itself. But that's taking into account, everything the model's outputting, the state, the undelayed trajectory, edicts, release times, TMIs, that type of information. What other demand is on the runway? So from the perspective of scheduling, if we jump back to the, I'm just going to go ahead and actually jump through the metering so we can just do the demo for now. Yeah. So VIP movements aren't electronically communicated. That would be coordination still between the tower and the ramp. That it's coming, and during that time, probably maybe say the ramp is closed, but everybody knows at that point that it's coming. Yeah. Let me also talk about overhead stream scheduling, as that was a major advance at Charlotte. So on that timeline, now that we know when a flight's going to take off, we do red space, green space, similar to IDAC, but we're putting all the other demand on there with the flight at the same time. So the green space says this is the time when the flight can take off and fit into the overhead stream. The red space says if you take off at this time, that flight's not going to be able to fit into the overhead stream going to the destination. So we're also displaying the edict and any miles and trail that's associated with it. And then we're also doing pre-scheduling. So Bob is going to have an entire session on the release times and pre-scheduling. But we're pre-scheduling into Atlanta and ORD. So at 20 minutes prior to earliest off-block time, we electronically send a request for a release time to TBFM. If a TBFM is in auto mode, it'll automatically respond back and say yes or no, you can have that time, and it'll give you a time that it can make if it can't make that specific time. If TBFM is requiring a TMC there at the center to make a decision, the TMC will see that request, make a decision on it, and that'll come back electronically to the tower and electronically be communicated to the ramp as well. So that prior to the pilot even saying, hey, I'm ready for pushback, they have a release time. So there's a lot more certainty about how much delay they're going to get into the overhead stream. And then I'm just going to jump through surface metering. There's a session right after this talking about surface metering. But surface metering, basically, once we have the demand and schedule produced, they can enter targets for how long to hold at the gate. We'll talk more about how this all works in the next session. Once metering gets triggered, then the ramp controllers are given a time to honor to take hold at the gate instead of in the active movement area. They hold the flights at the gate and then push back when that timer gets down to 0. So at this point, I'm going to go ahead and, Bobby, if we could jump back over to the other screen just to kind of spend the rest of the time that we have here with the demo. So first, if you want to demonstrate the release negotiation, or are we about out of metering? Yeah, it looks like we're about out of metering actually. So let's, yeah. So right now, this flight already has a release time. It's a little hard to see, but this white thing here is a filled-in lightning bolt, meaning that we are in automatic mode with TBFM, meaning there's not actually a human on the other side saying yes or no to the requested release time. Right now we're saying this entire line is green available, so you can just request the time that's currently there that we're saying we predict it's going to take off at this time, send that request over, and then we immediately get back an APREC. We highlight the APREC as green, meaning we think it's going to hit that time. If it's yellow, we're saying that flight we think is going to get there a little bit early, and then red means we're predicting it's going to be late. So, for example, Sure. So he's setting an unrealistic push release time. So it's going to say, no, we don't actually think you can make that time. That just gives the TMC a quick view. They can see, hey, that flight is probably not going to be able to make that time. We need to go ahead and renegotiate. Because they have the red space, green space, they can see what times are available and can make an informed decision about when the flight can actually get to the runway, and do we want to shoot for an aggressive time, or is it worth, you know, being on the safe side? So in that case, Leong just selected a slot on the timeline by clicking, and so they can see the green space and say, go ahead and give me that time. You know, today, right now, that's the TMC. The pilot gets to the spot at Mini Airport and says, I need to go to this destination. Okay, wait, I got to negotiate a release time for you. So the ground controller yells over to the TMC, says, hey, I need a release time. TMC gets on the phone, calls the center. Center says, let me check the timeline. Okay, you have this time. Then the TMC has to yell it back over to the ground controller, and then the ground controller has to communicate it to the pilot. With this, it's all electronic, with the last step being to the pilot being verbal from ramp control. But when we first went to Charlotte, we said, we're going to implement a new procedure. Basically, when the pilot calls for pushback, they're going to know that they already have need a release time from their PDC. And so, you know, they would, prior to pushback, contact clearance delivery. Clearance delivery would, and the TMC would negotiate a release time electronically, cutting down on a phone call. And then that time that they get back would go to the ramp control. The ramp control sees they have a time. They know they're good for pushback. And then the pilot would also get the time. So it's cutting down, you know, the ground controllers having to do less work. And so we've seen a big benefit from that.
Excuse me.
Yeah, go ahead.
When you say release time, you refer to off gates or off runway?
Off runway, thank you. I should clarify that. So this is APREC, or call for release programs. This is TMA, TBFM, either into the overhead stream to hit a miles and trail at a boundary, or to fit into the terminal airspace at the destination. The TMC can also see those times on the map, so they know where the flight is physically in the airport if the flight is taxiing. And then if we go back to the ramp tool, we can, let's see if we have any gate holds. Up at the top there is a gate hold. We're past the end of the bank, so metering is done. But that flight got it very late. APREC, that's I think one of those ones that Leong was experimenting with. So we're saying push back in 60 minutes to comply with that release time. So that hold on the gate gives you an idea of how long you need to hold there to actually comply with that release time. During metering, you would see similar type holds on all the flights going to a specific runway, saying hold at the gate for 5 minutes, 2 minutes, 10 minutes, to reduce your excess taxi time. So managing metering happens with the surface metering display. So if you could switch over to the... Yes, yeah. So this is, you can see there was a metering program recommended at one point for 3.6 center up there, that top bar, but it's now obsolete, meaning we're no longer recommending it. This graph here shows what we call the excess taxi time. So it's how much time you're predicted to taxi beyond unimpeded. And we're trying to match that to a target. In this case, we set a low target just to trigger metering as an example. Right now it's set at 5 minutes, which is unrealistically low for Charlotte. but each dot represents a flight, and we're saying, how long do we predict this flight is going to be beyond unimpeded? And so it just gives a quick glance. You can see the banks there clearly defined, with each peak is a different bank. And it just gives a quick view looking out ahead. What is the demand going to look like for the rest of the day? And are we going to have large excess taxi times? And when metering happens, it'll show up as a bar up there saying when metering is going to happen and what the status of that metering program currently is. There's also the metering parameters option where they can set the targets and change those numbers as well. So they can change the targets per runway. In a few minutes, we're going to save some time for questions, but in the few minutes left of the demo, if you go to STBO and we can pull up a couple of features that we've added where, for example, we have a taxi list where we're trying to kind of mimic ARMT type functionality so they can see what the current reportable delays are on flights. And which flights, how many flights are taxiing to each runway. Also put in a fixed demand list showing how many flights are going to each fix, which is similar to a display that's currently available in the TSD as part of TFM. But we're just kind of trying to show what you can do with the data when you have the better prediction accuracy that's going to be available at TFDM. TFDM is going to be publishing the data out not just to industry, but also to the FAA. And so once TFMS starts integrating this data, TBFM starts integrating its data, this is the whole 3T concept, it makes those systems perform even better. That's one big thing that we see is, right now the airport surface is a black box, as many people have already said. Once you know with much more accuracy when that flight's going to take off, you can start making better predictions about what is the airspace demand going to look like. What is the demand at when you can predict the takeoff time, you have a much better accuracy of when the flight is going to arrive. So you can start getting better arrival demand prior to the flights even departing the airport. So this is showing, arrival and departure counts per runway. No, that's fine. And then if you go to create and then do a table for the fixed demand. This just gives a quick, which flights are predicted to take off over each fix over the next 15, 30, 45 hour. This view is currently available in TFMS, but it's based on, just nominal taxi times and no deconfliction at the runway. But once you integrate TFDM and that data gets published out, this can be much more accurate so that the tower has a much better view of what the demand is going to be like over each fix. A couple things, it's a little too late for metering, but if we go back to the ramp display, in the ramp display, the ramp manager has the ability to mark a flight as a priority flight. What that does behind the scenes is create a substitution between flights. So this is a priority flight. We want to reduce any assigned gate hold to that flight. And during metering, that will drop the flight down and give it an earlier pushback time. So you can just mark a flight as priority from the flight menu. Yeah. So for the ramp tool itself, it just says, hey, ramp controllers, this flight is a priority. You probably want to get this flight off the gate and get it out there to the spot as quickly as possible. But behind the scenes during metering, it's actually doing a swap amongst the same airline flight. So it's not penalizing other airlines. It's saying, okay, American, you consider this flight a priority. Let's figure out how we can do some swaps with the times you've been assigned to reduce the gate holds on this one flight. So we're up to 15 minutes left. I wanted to open up the floor to questions.
Is there a capability or a discussion about some of this data being available in the cockpit, like through PIMs or DCL? Maybe just some bits and pieces of it as information directly to the pilots instead of the ramp towers and so forth?
I think definitely that's a great option. You know, with electronic flight bags and things that are being provided, airlines can provide a lot of this information directly to the cockpit, and figuring out how to get that data there, I think, is going to be a little bit of a technical challenge, but I think it's well worth. Instead of the ramp controller having to say, "Hey, you have a release time of this," or "You have an edict," go ahead and shoot that time over to the pilot. Yeah.
I have a few questions submitted, through this web application. So let me just, there are a few very good questions, and thank you for that, submitting the questions. So in the order of popularity, let me just pick one related to RTC. If airline need to build their own GUI, is there a standard set or requirements for coordination that will be required to participate?
Yeah. So I think, as a minimum, to participate in surface metering, you need to be able to display the TOBT and TMATs to your ramp controllers, or at least get it to the pilot somehow. So that would be for metering. I think there's a lot of benefit to be gained just from the common situational awareness. We turned that on at Charlotte, and initially there were some questions about, well, this is a new ramp tool, are we really going to like this? But then just having that data there electronically, the ramp controllers really gravitated to it. So I think looking through that TTP data set and seeing what is there, I think the runways, the TMIs that are, right now you got to look at the OIS page and figure out, okay, I see there's this, but then I got to match it up to my individual flights going to this destination. The fact that you can display these flights are going to have, this miles and trail or this APREC restriction electronically, I think is a big benefit. I think as a minimum set, just being able to see the TOBTs and TMATs is kind of the baseline requirement to do surface metering. But I think if you just start kind of with that baseline, you're missing out on a lot of benefits that TFDM has to offer for you as airlines.
Okay. All right, let me go to the next question here. If there are discrepancies in data from multiple sources, do you have a hierarchy as to which one you use?
That's a very good question, yes. Yeah. So we do have a set of hierarchies. We spend a lot of time in the fusion and data mediation as to how to figure out which data sources we trust more, and how to deal with discrepancies. For even something as simple as call sign. Sometimes we get the original call sign, but then the call sign has to be changed because there's two flights with similar call signs. And so one system publishes the new call sign and one system publishes the old call sign. So which system do we trust for call sign is something that we had to work through.
Yeah, I believe there is a session to discuss all this fusion and data processing.
It's ending right now.
Oh, it's there, right?
But it'll be recorded, and the slides are up there on the website. And as I said, also, we did a full day on this at Swift 2 sessions ago.
Okay.
I have a follow-up on that. The industry is working on the ADA side of everything, is working with something called the AIDX. I think a lot of us are aware of. There is, for example, a leg identifier in there. Is this something that you intend to incorporate in your data sets to make it easier for downstream systems to actually figure out what flight is this?
Yeah, so there will be a unique identifier. We have a unique identifier, which is obviously useful. But then, which leg of the airframe it is? I think with some of the data that the airlines can actually publish now is tail. There really wasn't a good way to get tail information into the system prior to this new data exchange that was available. So the fact that airlines can actually get tail in means we can actually, so we track legs of flights and line of flight to detect gate conflicts. The fact that the airlines can actually send that data in is huge, to being able to figure out which arrival is going to turn around and go out as which departure. It's not currently a data element that we're publishing out. It's a tricky thing to actually figure out a lot of times and get right. We've found that has been one of the biggest sources of difficulties. We've actually had to give the ramp managers a lot of ability to make manual inputs to get it right, because arrival lands and it's going to be at the airport for 12 hours because of maintenance. Well, where is that airframe right now? That airframe, that data is not published to the FAA in any form, and it's often hard even for an airline to track. Has it been towed off to the hangar, or where is it now? I think that's definitely an area where better data exchange could be helpful.
Yeah. There's one question here in the list. It is interesting. Are DOT tarmac delay times automatically tracked and prioritized using this tool?
So we do have, we don't have any DOT delays, but we do highlight flights that have been off the gate based on the DOT rules with progressive, like they're circled and, you know, starts out yellow, then orange, then red as they get closer to the DOT rules. And that highlighting is both on the ramp tool and on the ATC tool, so that there's a bit understanding of which flights have been out there for a while.
And I'd like to tag onto that. You have to be careful that you don't put too much on there. I would make that threshold a little bit narrower. I know on some of our third-party software, airlines, things like that, you can set them up for 60 minutes, and it gets too busy.
Right.
When you're really concerned about the critical flights, the ones that get within 30 minutes of going back to the gate or wherever the gate is.
Yeah. Yeah. You can definitely make these screens too busy. And there's been a lot of back and forth with the ramp managers and ramp controllers at Charlotte to figure out, okay, what actually is useful for you at Charlotte. And so back to the very first question about, you know, what is the minimum requirement for you know, integration with TFDM? I think a lot of it's up to the site and to your individual ramp controllers and users to figure out what information is useful. At Charlotte, the runway is key because that drives which spot you go to. But at some airports, you're going out an alleyway and the spot doesn't change. And so that runway information may not be as useful to you if it doesn't change your spot.
I think, just real quick, back to your experience in Charlotte, if you had a gate closure, did you letter that? What my question is, you know, currently, if we have a departure gate closure, it's closed until somebody decides it's open.
Right.
And then we start to pull airplanes that way. I'm wondering if, in your experience, is the TMC able to look ahead and say, okay, at some point, I think this departure gate will be open, and I'll predicate all the algorithms, what ATD-2 does to plan for that.
Yeah.
Because we do have tools like the RAP tool that basically kind of assist us in that, so I'm curious how that would work.
Yeah. So we give the TMCs the option of either saying there is a set end time, and most of the ones that come in through NTML have an end time, you know, which is, how good is that? But at least give some end time. We also have the ability to say, we don't know what the end time is, it's TBD, and at that point we just take the flights out of the schedule altogether. We also can say an alternate fix, so we say this fix is closed indefinitely, but we're going to be routing them over this fix. And so that will shift the demand over that fix, and that's a lot of what we're seeing in phase 3 there at DFW. Is you know, not sure when it's going to open, but and I'm sure John and others can speak to that more in later sessions.
You talked about the interaction between this and TDFM to get the operate times. Is there any functionality or is there any communication between this and FSM? If an aircraft has an edict time where it would try to closely compare an operate time and an immediate time to try to get those aligned, or if there's a functionality behind the scenes that if this is the only place that it's going to fit into the timeline, to go back to FSM and interact with it to have a slot or something through a substitution.
So we have from, so Leong here is showing the first option from FSM, the GDP gets sent out. We have an edict. So we're displaying the edict over there on the right. We're predicting the flight at that edict, basically. We actually have a little bit of a buffer. We're trying to get it there a little bit early. That's the CTD buffer for those familiar with TFDM and Surface CDM. That's the trying to get the flight to the runway a little bit early. But it's a 23 off time. We're predicting it down at 21. So we're showing the TMC, hey, and then when you click on it, that yellow box is the edict compliance window. That just gives them a cue, try and find a release time within this window. If there's nothing available inside that window, that's when it gets trickier. We don't go back to FSM. There's no way to go back currently and say, do a swap or something like that. I think as the 3Ts get more integrated, I think that's definitely an area for consideration.
Say a little bit more about your surface modeling, taking into consideration the cues that develop and sort of interacting that with miles and restrictions and things.
So, we do detect which flights are in cube. Right now it's based on a polygon. We're detecting where they are on the airport surface. And if you click on a flight, actually, I can't remember what the key cut, pull the trajectory of a flight. Is it all R? Yeah, so he just pulled up our predicted trajectory for that flight. So we can see kind of what the predicted order is at the runway. At Charlotte, we do detect which flights are part of the miles and trail. We don't update our schedule based on the miles and trail, actually, because there's a lot of uncertainty about the order. And we didn't want to be penalizing flights during metering for the runway based on, like, hold this one flight back because of, we wanted to, in TFDM, there's a separate thing called metering to a miles and trail, if you remember, and just to make sure there's enough of a front loading of that miles and trail restriction so you don't miss gaps in the miles and trail. We started kind of simple. We didn't want to jump into too much at Charlotte, so we just said we're not going to separate flights due to miles and trail. At DFW with phase 3, we needed to predict how much delay there's going to be so that you can see should we take a reroute. So in phase 3 with our terminal scheduler, which is the other sessions, we do predict takeoff times based on miles and trail, actually merging DFW, Love Field, and all of the feeder small airports around the D10 Metroplex at the fix and spacing them with miles and trail at the fix.
Okay, I have another question here. The ATD-2 system calculates ETOT and ETA at departure fix based on operator provided EOBT. That's true. In the future, will TFDM do this, or will operators need to calculate those times on their end?
Yeah, so TFDM will be calculating it in ETOT. So we say TTOT, ETOT a little bit interchangeably on ATD2. In TFDM, it's called an ETOT. This is the estimated takeoff time. It's the best prediction of takeoff time. And TFDM will be producing an ETOT based on the EOBT at the larger facilities with surface surveillance, using very similar stuff to ATD2, predicted taxi times, what other flights are already in front of it, what are the runway rates, that type of information. So that'll be available. That is available in the ATD2 demo version of TTP, and that will be available in the TFDM TTP feed. Okay.
Yeah, just one more question. All right, I have one off the list. In the current field test, is the gate release time based on when the pilot calls ready or based on the flight's EOBT?
Yeah, so that's actually a good point about the readiness information. That's a data element that we're capturing in ATD2 that's not really one that the airlines will provide to TFDM. And for an airline to actually measure your benefits that you're getting out of metering, it's very useful for your ramp tool to capture the readiness information. So when the pilot calls ready, the controller either clicks on the flight and says push back the flight or says hold the flight. I don't know if you could demo that real quick, because last minute on ramp tool. But when they make that entry, we capture the time, because that's the best information about when that pilot was actually ready to push back. And so then we can really find, highly instrumented version of how much gate hold how much time did that flight really hold on the gate. But the time that we're telling the flight to hold at the gate for metering is based on the EOBT, because that's set prior to the pilot calling in for pushback. We're very thankful for the airlines that are working to develop their models for EOBT, and we're getting better EOBTs from all the airlines as we speak. So Leon just put that flight on hold. So now there's a countdown timer saying how much longer that flight has to hold to comply with that APRIC release time. And so we're saying if you push back in 38 minutes, you should get to the runway with a little bit of time to spare to meet that release time. And we've got buffers built in so that if there's uncertainty in the pushback times, we can still make that time most of the time. And we've seen compliance improve, and I'm sure Bob will talk about that in later sessions.
All right, I guess time is up. So thank you again very much for attending this session. And